Ah, Hello Swaroop, hello Peter, hello Rohit.
Hi.
Hello everyone, so I'll just wait for a few more minutes, then we'll start. Okay, so hello everyone. Before we start, welcome to the session on capacity planning. I would like to introduce myself first. My name is Shashant, and I am in performance engineering since the inception of my career. It's been 16 years that I am working in performance engineering, and capacity planning has been a part of that performance engineering, in which I have worked with one of the biggest retail markets, biggest one of the biggest banks, and currently I'm working with one of the biggest companies. So that is where I come from, and I have a deep knowledge about what the capacity planning is and how we can help the companies to grow and to stabilize their environment. So I'll start with the session, and in case you have any questions or queries, either you can put it on the chat or you can raise your hand. I'll be happy to help you. Okay. So coming on to the program that we will be running, that is the capacity planning. Here is the overview, what all modules that we will be discussing. So I have divided this module into the seven different sub modules. And I have divided capacity planning into seven different modules, starting with foundations of capacity planning, workload and demand analysis, application level capacity planning, database capacity planning, infrastructure and network capacity planning, and cloud capacity planning. All these uh, modules are further divided into the subsessions. Like for the foundations, I'll give you an example that, like for foundation of capacity planning, I have five sessions within that, in which the first session is capacity planning, why it makes or breaks the systems. Then the second session would be capacity planning lifecycle. Third session would be core terminologies that we'll be using across all the modules. Then types of capacity planning, and the fifth module will be capacity planning in the software development lifecycle. So this is just an example that I'm giving you, that what we will be covering in across this course, that is starting from the foundations of capacity planning. It has total, if I talk about it within the seven modules, there are 32 sessions that we'll be uh, working on throughout this journey. So hopefully we'll all be aligned on this, and we will be working together to learn what capacity planning is. And I hope that everyone here who has joined, they are aware of performance testing, performance engineering, and then that is where we are moving to the next level, that is capacity planning. And we'll be helping, once you complete this course, you will be capable enough, or you have the better understanding on how you can help the companies to stabilize the environment, to help them to reach maximum number of users. And what we see during the e-commerce, or during the festive seasons, the e-commerce website, they sometimes go down. So that is where you will understand the terminologies that comes for the capacity planning. Okay, this far are we good?
Yes.
Yeah. Okay, so we'll start with the capacity planning. The first, that is the for the first module, that is the foundation. I'll start with the first session, that is capacity planning, why it makes or breaks the system. So, what is capacity planning? If any one of you can help me understand, what is your understanding of what is capacity planning is? Anyone? Okay. So before we begin, I'll give you a scenario. This, like, I want you to think about the last time major outage that you witnessed, either in your organization or as a customer in any of the applications that you are using. There could
ঠিক
be
আছে,
any
ম্যাথ বই তো
outage.
দিতেই হবে আজকে।
Sorry. Okay. Would request everyone to go on mute. If you have any point, please raise your hand or uh, unmute yourself. Okay. Very so what happens that sometimes we see such outages, and the explanation that we get from there is that traffic was higher than expected. What is traffic? Traffic is something, the number of users on that application was higher than expected. So you might have seen in the current World Cup matches, you see on the left corner of the screen, they show the number of users who are viewing that match. So that is the traffic. So the system was not sized for this load. So sometimes you say that, "Oh, okay, application was taking too much time to load." Then the explanation you get from the organization or the company, that as a customer you get that the traffic was too high and the application was not able to take that load. So what they were really saying is that they did not plan for capacity correctly. They were not aware that how many people will be accessing their application. They didn't forecast that. So today's session is not about servers or cloud configurations. It is about understanding why capacity planning determines whether systems survive, success, or collapse under it. So, what what is the general understanding of capacity planning is capacity planning is defined more majorly as a strategic forecasting. It is about predicting future resource needs before demands exceeds what the system can handle. So majorly everybody thinks in this manner that okay, this is some kind of a strategic forecasting. We will have to analyze how many users we will see in the future, and we will have to put our resources in that manner. But it is it has two more steps. First is strategic forecasting, in which we will predict the resources. The second one is the risk mitigation, where we are identifying limits and failure points before any customers do. Then the third one is business alignment. Our infrastructure must support growth, revenue, and customer trust. So this means what these three significantly say is that it is not an optional thing right now. The current environment, the current era that we are living in, we are having applications where we have millions of users or millions of subscribers, and they can log in at a single time. We can take an example of big billion day sale and the Amazon sale and the Flipkart sale. So they the people rush towards that, and that is where the capacity planning is not an optional thing. It is how you or we can protect the business from its own success. Okay, so we can will have to define. This is what defines the capacity planning. We are not talking. We will not be talking about the CPU or RAM. So it is basically a strategic discipline that anticipates when systems will reach their breakpoints and ensures that if there is a huge traffic that comes onto the application at a at a certain time, whether it will be able to handle that situation or not without degrading the customer experience. So if as a single user on that app, if you load that application, you move from one page to another, it takes 1 second. Then if there are 100 of users also in that application, the experience for you should not be degraded. So in modern cloud environment, the infinite capacity that everyone says, okay, put it a dynamic scalability. Let's put it. The infinite capacity is a mask, but because everybody knows there is a limit that exists. You put a dynamic scalability, either horizontal or vertical, for your servers, it will give you a cost. There is a cost behind it. So, and then at a certain point, there will be a limit. So, the infinite capacity in this cloud era also has a limit because infinite capacity is a mask. We can talk about database connections, API rate limits, network bandwidths, and downstream dependencies. All these are the limits that put our infinite capacity at risk. So that is what capacity planning is. It has three major points, that is strategic forecasting, risk mitigation, and business alignment. Are we clear with this? Any questions on this one? Okay.
Good.
Okay. So move on to the modern system challenges. What is this? What is the modern era that we were talking about? What are the challenges that the organizations face or the applications face? So modern system challenges are two: scalable scale and unpredictability, and the cloud illusion. Why? What I said earlier also was that user growth is currently is exponential. It is not linear. So if you have two users today, you cannot say that tomorrow you will have four users. You might have 100 users tomorrow. So it is not linear, it is exponential. Then you can take an example of flash sales, viral post, breaking news. These all these all things destroy the historical patterns. Second, the cloud illusion. Front end scale automatically, but when we talk about the backends, the downstream, these systems often don't scale automatically. So these are the two challenges that we face in the modern system, where we are unable to predict how many users we will get tomorrow because the user growth is exponential. And the second thing is cloud platforms, cloud illusion. Because when we say about what we say about the cloud illusion is that cloud platforms promise infinite scale that we discussed earlier. But in reality, it is a mask. There are multiple other factors that come into the system that actually destroyed this illusion, that is the cloud illusion of infinite scale. Any more points that you guys can think of, or you can bring up, because as per me, there these are the these are the two major system challenges that currently most of the apps face. So coming on to what capacity planning really means, we have to move from the beyond the traditional view that capacity planning is equal to the infrastructure sizing. We will have to move beyond that. Now, capacity planning is a multi-dimensional discipline that actually take into considerations technical, business, and operational factors. Here, I have mentioned five. That is, what is the transaction value volume? That means that how many requests does your system serve per second or per minute? What are the API calls? What business operations are processed in those API calls or in those requests? Then data growth. We are growing the data like anything. We have got the cameras that in a phone that are taking the images at 50 megapixel, and then we sync it to the Google Photos, or I know about Google Photos. So you put it on a Google Photos, and the data is like growing like exponentially. And then when you fetch that data, that is a complex data. You need a the the queries are complex. It has the indexing overhead. Third is peak versus average. You say, okay, on an average, I get 2 to 4 users or 6 users per day, or 100 users per day, or 100 users per second. What about peak? Next day you put something on sale and then you see the boom. You say, okay, I was not prepared for this. There are 10,000 users coming in my system in a second. How can I handle this? So a peak versus average understanding is very important. Then dependencies. There, when you create an app, or you have a particular system, that is not a standalone system. It has a third party services that are attached to it. There are APIs, there are database, there is an external system. You put a the payment gateway, that is the external system. So when we have dependencies, that also restricts our capacity. Third is user growth. As a business owner, you should have a visibility how much users you are thinking to grow in next 1 year, or in next 6 months, or in next 3 months. And you have to plan your system infrastructure, your system dependencies in that manner, that okay, next day if I get what I was expecting in 3 months, I should be able to handle this. So that is user growth. And the understanding of user growth comes with active users, concurrent sessions, and session duration. So what are these terms? We'll discuss it in detail in the terminologies, but that is what these are the factors that are responsible. So, as per me, capacity planning is fundamentally business risk management. It gives business owners business a confidence that yes, my system is stable, my system is in a situation that it won't break if I get a peak load during a festive season or if I put a sale next day. So when we talk about this, so when we say this slide is very important. So please, guys, if you have any questions, please ask me because these are five points that will come again and again in capacity planning. Okay. So I'll just reiterate. So user growth is not just a total users. It includes concurrent sessions, concurrent users. What is the behavior pattern? So 10,000 passive users are very different from 10,000 active users hitting a refresh button. Okay. Then the transaction volume. Transactional volume matters more than the users because a single user might generate dozen of API calls. Suppose he can click here, there, in like in within a second. That is quite of an engineering thing, but you think from a functional thing, but you think it from a capacity planning point of view. A single person, if he if he is not finding what he is looking for, then he will go ahead and click everything, and that will generate like 10 to 12 of API calls. So capacity planning must model workload, not headcount. Then the third thing is data growth that we discussed. Data growth is affects the storage, query complexity, and index performance. So systems often fail not because of the traffic, but because queries become too expensive as the data grows. As I told you, as the data grows, the data gets complex, the query complexity increases, the indexing overhead increases. Sometimes the systems fail due to the data growth. The fourth point is peak versus average. So this is very critical because what we say is on an average day on every day regular days you get an average load of 100 users per second, but systems fail at peak because your system was not ready to handle the peak load. Then the last one is the dependencies, as we discussed already, because your system as a standalone could be the strongest, but there are other factors also that can make it weak. That is the third party services, API, databases, and external systems. So these are the dependencies which we cannot ignore, and that can bring a big mistake in capacity planning. Now, capacity planning framework. There are three uh, capacity planning connects that are there. First is the demand drivers. What is demand drivers? We have capacity planning demand drivers, that is user growth, market campaigns, seasonal patterns, business initiatives. These are demand drivers. These actually create a demand for you to look into the capacity planning. Then system capacity, compute resources, database throughput, network bandwidth, and storage limits. When you see any of these going into the red, that is the time you bring in the capacity planning. Then failure points like bottleneck, saturation points, dependency limit. If you see any of these 3 points and any of the factors that are red, then you go for a capacity planning. So these are 3 points that actually connects all together to bring the capacity planning framework. When when demand approaches capacity, system degrade. So our goal is to maintain a headroom. without wasting money. And how do we do that? We optimize the system. As a capacity planning, as a performance engineers, we have to modify the configuration. We have to guide the business or to the DevOps team. Okay, you change this configuration in this system. It will it will be able to accommodate 10,000 more users. So that is how we will have to create a headroom. Just understand this thing in a perspective that capacity planning and as a performance engineers, when we do a capacity planning, we cannot go and say to the business upfront that okay, you increase two more servers, your issue will be resolved. No. As a performance engineers, when we do a capacity planning, our first and foremost agenda should be to make the current system better so that it can resolve the issue that business is facing. Any questions till now?
Hey, I have one question. Am I audible?
Yes. Yes, yes.
Oh, okay. Thanks. So, sorry, this is Nilanjan. I'm currently working as a technical architect in one of the leading bank in Canada. So, if you go
Mhm.
back to the previous slide, would you mind just going back to the previous slide? Yeah.
Yeah,
So
yeah.
here, this user growth, transactions volumes, as you can say. So currently, this user growth, I agree with you, but this
Mhm.
transaction volume and then data growth. Currently, if we go to onboard any of the cloud platform, maybe Azure,
Mhm.
GCP or AWS, they
Mhm.
should take care of these things automatically, right? That's the main point that we are currently going to the cloud, right? We don't need to worry about these things. As you mentioned, the
That
auto
is,
scaling things, right? That should
yeah.
automatically be taken care by the underlying infrastructure, correct?
That is where I was saying that the auto scaling is actually a mask. The auto scaling has also got some of the limits. The data growth, when you say the data is growing exponentially, you will auto
Hmm.
scale the system, but when you fetch, as the data grows, the data becomes complex, so the complexity of the query comes into the picture. If the query is not optimized, then you
Yeah, then you have to tune the
the,
query. Correct.
exactly,
Hmm.
exactly, and that is where the auto scaling, the capacity planning, don't think from perspective that okay, if I put the cloud, as I mentioned in the previous slides as well, that the auto scaling is actually a mask. We say, as you mentioned, that we say that okay, auto scaling can be done and these things can be handled, but at a certain point, these auto scaling will keep on growing and growing and growing. And what will happen when you auto scale? The cost gets added, and when the cost gets added, apart from that, there are other factors also that actually influence the breakpoint for the system.
Hmm.
So as I mentioned, suppose you auto scale the cloud platform, the cost is increasing. That is not a problem for if you have a big business, it's fine at a certain point, till certain point. Okay. Now comes the query part. The query is the data becomes complex. The query becomes complex. You have not tuned that, and the system breaks. You got my point. So there are other parameters also that affect the capacity planning. Also, there that is not from the infrastructure level, but from the each and every part. So I'll give you an example. Suppose uh, there is a configuration for garbage collection. If you guys know, so when we if we see that a memory is going very high, then we what we do as a capacity planning, we don't say okay, increase the memory. No, as a performance engineer, we will have to look into the best possible value for that parameter to help what the current system can accommodate. If we have reached the threshold of the current system, then we can move on to the increasing the infrastructure. But firstly, we will have to completely utilize the current system capabilities. Am I understood?
Yes, to
Hello.
me.
Thank you. Okay. Any more questions? Okay. So moving on to the next part, case study. The that is from the banking sector. I'll give you the simplest one, salary credit day. So this is with in respect to the major retail bank that experiences outage on the salary credit day when millions of employees simultaneously check the balances and made transactions, because as soon as you get the in notification that your salary is credited, you go ahead and see what is the balance, if there is a tax deduction that was done, whether it is higher or on the lower end, or you start making payments because someone's rent is due, someone's loan payment is due. So this happened with one of the retail banks in which they millions of employees, they started checking their balances and making payments. Then the mobile apps timed out and online banking became unavailable for us. What was the root cause? I'll will discuss that. Database, there is a connection pool parameter that exhausted within 15 minutes. So that database connection pool, that parameter was not actually tuned. Then authentication service, because this is a third party, the authentication service that was used, that was overwhelmed by the concurrent logging attempts. Rate limiting or downstream core banking system triggered aggressive throttling. No circuit breaker pattern implemented to fail gracefully. So what happens when we say that as a capacity planning or as a performance engineer, when we do the capacity planning, then we also think about, okay, suppose we have done the best capacity planning, we are thinking in all the major areas, but if still we think that okay, at certain point it will go on fail, then there should be a backup in which the user experience should not be destroyed, because it this has been observed and this has been seen in this current era. There are n number of applications in the market, there are n number of banks in the market. If you are not good in providing the customer experiences, the customer will not be loyal to you. He will move on to the next one as soon as he thinks. So that is very important, very much important. When we say if you fail gracefully. What was the business impact? It was $2.5 billion was lost in fees, in transaction fees. Apart from that, there were some regulatory fines because they were not able to handle the situation in a proper manner, and they were flooded by 85,000 plus complaints. So that is one of the case studies that we have from the banking sector, in which in which we were seeing this issue, and then we uh, gone ahead and helped this bank with the capacity planning. Moving on to the e-commerce, this is a very generic thing, and I have since the starting of the first slide, I have been talking about this. The flash sale catastrophe. This is like a common case. Everyone might have seen this. You put There was this OnePlus sale that came like around I think 1 or 2 years back. It is there was OnePlus phone was launched, and within a second the app got crashed. Because there were n number of I don't remember the number of users, but they were quite a huge number of users that were trying to get that phone. So that is one of the biggest examples in capacity planning, that way that if you get a sudden uh, traffic of users, then how can you handle that, whether your system is capable of handling that or not. So this is for a fashion retailer that we work for. So marketing reached like 5 million users. Engineering uh, from the engineering team, they guess that okay, if we are seeing 1,000, then we might get 3 times of the normal capacity that we have, and they did the estimate on that basis, but the traffic got 10 times. So database slowed, the add to cart got exploded because of the memory issue. Payment APIs were not working because that is a third party dependency that they have. So the customer was unhappy and they were not able to make the sale that they thought of doing during that sale season. So that is this is one of the e-commerce case study that we have, in which a popular fashion retailer, they planned for a 24-hour flash sale, and they actually put a huge discount that was 80% on the premium inventory. As per marketing team, they were thinking that they have reached 5 million users, but when they and as per the technical team, they were ready with the 3x capacity. But when the actual sale started, it was 10x users that they saw. So that is also one of the examples from the e-commerce. This is payment gateway festival surge. We have been talking about. This is the festival time that where the on day one the festival launch, and Diwali shopping begins. Traffic increases to 3 times from the normal baseline. System handle load with a minor latency increases. Many of us have seen this, that when you go on to, you have okay, everything was working fine, but till we reach the payment gateway, it is not good. Correct. So day three, there was a peak load, like 800 transactions per second, where on an average it was 200 transactions per second. That was 200 per transaction per second was actually planned capacity that they did, but they were getting around 40% more. So they started facing failures. For 3 hours, their whole payment was stopped. There was no payments that were done. All the requests were getting paid. Emergency scaling was deployed. Manual transactions, what were done during the with the bad jobs, they were done manually. 60,000 transactions were processed late, causing settlement issues. So, as you might have seen, if your payment doesn't go well, then your account is debited, but you are not able to make a sale, make a purchase. So, what happens that you connect with the customer care, and they say, okay, sir, that there was some issue, and we will be refunding your amount. So, that were the settlement issues that were done. So, what was the business impact? $8 million were lost in the transaction volume. 150,000 plus failed payments, which is like huge. So that is how the payment gateway festival surge was actually had issues. Now this is one of the interesting topic that we get every now and then. That okay, I'm a performance tester. What is the difference that uh, we do as a capacity planning?
What was the root causes? Sorry, in the root causes section, you said the IDM potency not implemented for the retry logic. What is this one? And the first and second, if you don't mind, can we
No bulkhead
explain this
isolation
one?
between payments. Okay, so there was no what happens when you do a this payment. Okay, if it
Mm-hmm.
doesn't go well, then there should be a retry. There is actually a retry mechanism that we put in a payment gateway. Okay, once it
Correct.
is not done, then the API again goes.
Hmm.
That logic was not put
Not
properly.
there.
So
Hmm.
yes, that was there, but the point was that it was only giving two retries, and it was also giving failure in the backend. So the API was trying the second time, but during the first time only, it was giving the error in the database. So it was creating a wrong entry into the database that okay, the retry is done, whereas the retry in itself was a failure.
Got it.
Got it?
Got it. Oh,
Huh. So then this was no bulkhead isolation between payment types. So was that there when you go into the payment gateway, there are multiple sections that okay, whether you want to do a net banking, whether you want to do a card payment, where that are the different segregations that you get. The problem was that each and every option that was there, that was in the backend, it was hitting only the two APIs.
Got it.
So you use net banking, I use UPI, someone else uses something else, but in return, everybody is using. All of us are using only two APIs in the backend. So there was no isolation between all the payment types.
Got it. Got it.
Okay.
Thank you.
Yeah.
Thanks for the explanation.
Thank you. Thank you. Okay. So what is now coming on to this one? So as we get to this question that okay, performance testing and capacity planning, what is the difference? So there is a there is a very slight line, very thin line between this performance testing and capacity planning. If you see, as a performance testers, what we do is we measure the what is the current system performance is under a load. That is okay. We say okay, at 1000 it is breaking, at 800 it is working fine. So it is the current ideal load that it can survive, because that is what we are testing is we are testing the current system performance. Now what is the time frame that we are looking at? We are looking at the current time frame, that okay, currently we have 200 transactions per second. We are testing only for 200 transactions per second. If it fails, we report to a dev that okay, this is breaking. Dev checks, dev rectifies that. We again test for 200 TPS. We are not thinking beyond that. Okay, if today it has 200 TPS, what will be the future? Then who takes the ownership? It is always QA, performance engineering team. I'm just talking about performance testing right now. I'm not moving on to the capacity planning, because when I speak of performance testing, you will understand how performance testing is different from capacity planning. So the outputs that we see are majorly what people say, that okay, what is the error rate, what is the throughput, what is the response time, what is the what were the bottleneck identification. That is the majorly the presentation text that we create as a performance testers. Now, as a capacity planning, we are not looking at the current system. We are looking at the system that should be capable of handling the load after 1 year or 2 years, and at what time it will fail. Time horizon, it is always future facing. We talk about 3 months, 12 months, or ahead. Who is the ownership? Who takes the ownership? Everyone. Architect, SRE, business stakeholders. Because business tells us, okay, I'm as a business owner, I'm thinking that within 3 years we'll see around 100,000 users coming onto our app. So that is how the business is involved. That SRE, they actually provide us the infrastructure definition. The architect, they provide what is the current infrastructure design, which API flows from where, what is the mechanism that is used, so what is the load balancer that we have used, where is the caching that has been implemented. Everything is there. That is where the ownership lies with everyone. Output. So we do, as an output of the capacity planning, there is a capacity forecast, scaling plans, risk assessments, budget requirements. So we will optimize the system. That is the capacity forecast. We optimize the complete system. We say, okay, as per the current system, if we don't go into the new scaling of the system, then the current system will scale to this much, because we have fine-tuned the configurations that can be done. A scaling plan. Suppose if it doesn't work, then what is the scaling plan? Where is the bottleneck that we see as per the current? If we are moving on to the peak load, then where is the bottleneck, and where should be the scaling should be done? What is the risk assessments? What is the major APIs? Where are the major database queries which are creating problems? Then budget requirements. Obviously, when you talk about scaling, or when you talk about putting on the servers or anything, then you talk about budget requirements as well. Frequency, because the as we mentioned, as I said in the previous slides, that we are talking in an era where the user growth is exponential. where the transactional data is growing like anything. We are the data of a particular user is growing exponentially. So then it becomes a continuous process. It is a it either you do it quarterly or you do it half yearly. It depends on how you are seeing your user growth within the system. So that is how the what is that is the difference that we have for capacity planning versus performance testing. So as a key insight, I will that comes into picture that performance testing tells you where you are today. Capacity planning actually predicts where you will be tomorrow and shows you won't fail when demand arrives. So both are essential. That is where I said that there is a thin line, because when we do a performance testing, we require the same performance testing to be done for the capacity planning also. If you don't want to do a capacity performance testing during a capacity planning, then you have to rely on the logs, on the data, historical data that is available within the system. But the better capacity planning is done when they go hand in hand. You say, okay, I have fine tuned this particular configuration. You do a performance testing, and once you do a performance testing, you say, okay, increase the load to this particular number. Let's see whether it reaches that point or not. So they go hand in hand. But if you talk about in isolation, then performance testing tells you the current picture, and capacity planning gives you the future picture. Any questions? So everybody, we uh, as a part of the industry, IT industry, I have seen that that companies are moving towards the performance engineering and capacity planning, but still there are few of the drawbacks that we see that the companies fail, because they what they do, as I mentioned earlier also, that capacity planning is actually a regular exercise that you do, because you have to uh, always look into the audience, that okay, you have today I have 10 users, tomorrow I have 20 users, for day after tomorrow I have 30 users, whether my system is capable enough of taking that or not. So that is where it becomes a regular exercise. So what the most of the organizations do, they do it as a one time activity. They treat as it as a checkbox. Okay, you this is a checklist that all these things should be done to go live for our system. So as part of that, they do it as part of a checklist, and they do it once. Then cloud auto scaling, that is actually, I told you, that is actually a myth, because there are hidden details like database that transactional part. Then there is a queries that become complex. So there are these few of the things that actually involve where it restricts the cloud scaling also. Then downstream blindness, because they whenever sometimes the business only sees their own system, they don't talk about the systems that are integrated with it. They don't see the third party dependencies, they don't see the downstream systems, like payment gateways. Well, I give you an example of one case study we already seen. Then email services, then the legacy systems. That becomes bottleneck, because once the legacy systems, they are built on a particular architecture that you cannot touch. So they also, if they are integrated to your current system that is built on a current infrastructure, then that also creates a bottleneck. So that is where they actually don't look into that. They say, okay, this is my system. I want to get it uh, get it optimized and get it certified for a capacity planning, but they don't look into that also. Then there is no ownership. So that this is one of the biggest thing, because what happens that capacity planning, it sometimes the teams think that it is a task of a performance testers, performance engineers, or QA team, and that the development teams more majorly focuses on features Operations team, they look for the uptime. But as I mentioned earlier also, that that who all are responsible in this, that it is the problem of everyone. It everyone is a decision maker. Everyone is a person who there should be a scrum for the capacity planning in which everyone should be sitting. The business, SRE, QA, architect, everyone should be sitting, and they should discuss that, okay, this is the current situation, that we have current these many users, and this is the particular resources that we have utilized, and this is the limit. So no ownership that we see. Then reactive mode. So this is one of the things that is very common, because companies don't take it, they don't think of it as a shift left. That okay, we should be starting from the beginning and taking the performance engineering for capacity planning into picture from the first day while we are creating our application or creating our system. So what they do is, they once they get into the market and they fail, that is the reactive approach that they think of. That they then they go here and there like a headless chicken. That okay, we want to do a capacity planning. So that is one of the thing also. That is the reactive mode. Then business technology divide. There have been scenarios in which the business is not at all aware of what the technology team is doing or what needs to be done, because they are thinking in their own world that business is only responsible to bring the customers, to bring the business. They are not thinking from the technology point of view that okay, there is we are all dependent on the technology also. So there is a huge market of this kind of a organizations also, where there is a huge gap between a business and the technology. What are the key takeaways? So capacity planning is actually a continuous risk management, not a infrastructure provisioning. Then we have to look into the peak loads, not the averages, determine system architecture requirements. Business and technical teams must collaborate from planning stage. That is the shift left approach. Downstream dependencies often fail because before your own systems, because sometimes you have the bottlenecks on different third party and the API and all these systems. So that is the bottleneck that we have to look into. We have to deep dive into. Then auto scaling can solve some problem, but not all the problems. But there is another drawback to that, that if you do a continuous auto scaling, then there will be more problems rather than you're solving any of them. So systems actually don't fail randomly. That okay, something was you didn't put a salt into the while making a vegetable, so it didn't taste it good. No, it was, since it was always there, but you were not able to see that the issue was always there. So the capacity planning should be done, and should always be done in advance and should not be ignored. So these are the takeaways that we should be taking from these 6 points that we discussed above. Any questions from this? Okay, so this is the checklist for capacity planning. When you get into the business, into the process of capacity planning, this is the checklist that you should follow. System components limit. You should have a list of systems, a list of components that are there, and what is the limit of them, of those. What is the current capacity and current utilization? So all the resources should be mapped against what is the current utilization for those. What is the forecast demand? You have to connect with business for this. That okay, what are you thinking? How within 12 months, how many users you are expecting? Then once you start into when you deep dive into the into the systems, into the component, into this application, then you have to identify the three bottlenecks. Then you, as I mentioned, we have if we are doing with the performance testing, the capacity plan, then you have to define the load test. What you want to do, how much you want to do, you have to define the workload for those, and you have to execute that and traffic that you want in next 12 months, then obviously you have to get monitoring and alerts also, because when you are testing, you cannot look into all the logs or all the resources side by side. You have to put a monitoring and risk and alerts. Then scaling runbooks, where what is how to do a scaling? What is the critical thing that you want to do? Where you want to do a scaling? You cannot do the scaling of a service like anything. Okay, you this is not working. We will scale this. No. So what is the important part? Where is the maximum load? Where you want to do scaling? Where at on what kind of a scaling that you want to do? That is a kind of a runbook that you have to look into. Then obviously, as I mentioned, it is a regular exercise, so quarterly reviews. That okay, this was the capacity planning that we did in the previous quarter. This is the current user count that you have, and this is the capacity planning that we are that for this we'll be doing the capacity planning in this quarter, because we are seeing the users are growing more than what we expected. So that is how the capacity planning reviews to be done in quarterly, and then communicate plans. So you have to be transparent with the business. You have to be transparent with the DevOps. You have to be transparent with SRE. You have to be transparent with architects. So you have to ensure a transparent communication of capacity planning. Whatever risk you have identified, you have to tell them what are the resource requirements that you need. You have to be very clear with the leadership and the other teams that are responsible for this. Now, this is something that we'll be discussing in the further slides also, but here I just wanted to give you a picture that capacity planning for microservices and distributed systems. So, microservices actually uh, they alter the capacity planning while shifting from the monolithic resource allocation to complex allocation. That okay. There are few challenges that we face in the microservices regime in paradigm. So what is there? That is service to service dependencies. A single user can fan out to dozen of services. So capacity planning has to be done with the aggregate load and identifying choke points. So there is like you trigger one action, and then at the backend there are 12 APIs called 12 services called in the backend. So for capacity planning, we will have to look at the in these 12 connection points that okay, where is the bottleneck? Where is the bottleneck? Okay, so that is service to service dependencies that are there. Then cascading failure. So it could be a possibility that okay, there are a number of services that are connected to each other. One of them gets failed, and then there is a failure across across the system, because it can quickly propagate. So that is a cascading failure. Then distributed tracing. So essentials for bottleneck identification, because traditional monitoring we cannot put it in the microservices, because it as we mentioned, as we discussed, because there are n number of services connected to one another, and there is a we cannot put the current monitoring in this. We will have to visualize the request flow, that okay, this request was served by this service, then this service called to this. So we will have to identify, and we have to put the monitoring at each level. Then we have to take into the consideration the service mesh. A mesh manages inter-service communication. So there are two services that are communicating to each other. So one could be taking the 100 user load, but the second one might not be able to take that. So in that condition, we will have to take into consideration the service mesh also. Then managing many services. Obviously, there are capacity planning shifts from a few larger components to 100 of smaller, which are independently scaling services. So that is where the we have to manage with the there are multiple services that are all auto scaling, and we have to manage all those. So this is the current the current phenomena that we see with the while doing the capacity planning for the microservices system? Any questions on this? We will be discussing all this and then in the future modules in the future sessions. So as I mentioned already, we have 7 modules that I have planned for this capacity planning, and out of which, if I calculate all together, then there will be 32 sessions that we'll be doing for the capacity planning, and these all will be discussed there. So this is the cost optimization through capacity planning. We will that is what we say that balance waste and risk, right size infrastructure, optimize cloud spend, then measure a return on investment. So suppose there are 2 to 3 boxes for database, but out of three there is only one that is being utilized. So rest two are not properly utilized, or you have put them all in a manner that okay, each one is being utilized as a 20%. So still, if we put it together, then also we will have some buffers. So why to waste money on the other two? We'll optimize the one box and we will see if we can increase or enhance the power of or capability of that particular box. Then right size infrastructure, we could be possible that you have uses you have put small boxes where the large boxes were in need, and that is where you have started putting the n number of small boxes that is actually causing problems. So right size infrastructure is also important. Then optimize cloud spend, as we already discussed earlier also, that auto scaling auto scaling in cloud is actually a myth. There are a number of other factors also that hampers the capacity planning. So what is and when you put the auto scaling into picture, where have to put auto scaling, that is also very important. You cannot blindly put auto scaling in any of the uh, any part of the system. Then what is measure of return on investment is that is how many transactions that you are getting, and what is the cost per transaction. Then what is the return on investment? That means that the infrastructure that you have put up and the transactions that you are getting, if you calculate that, then what is the return on investment that you are getting from the current infrastructure, and where we can reduce that. So that is how we can as a performance engineers, when we do capacity planning, then this is also one of the pictures that we have to look into. And the cost optimization, when we talk about that, the business go crazy, because that is what they want. Every businessman, they want their systems to be optimized to take more load. And if you talk about that, okay, we will reduce the cost that you spend on infrastructure and all, then okay, great, you're onboarded. You do this for me. So that is where you have to think in that manner. So what is the just that we by proactively understanding the future demand and right sizing the infrastructure, organizations can significantly reduce both operational cost and the financial impact of system failures. So that is the how the cost optimization can be done from the capacity planning. So what, as we discussed in the previous slides also, this is how we build a capacity planning culture. Should be a cross-functional collaboration between each stream, business, engineering, DevOps, SRE, everyone. Then regular review meetings, capacity focused postmortems. When we say postmortems, we have to review everything. What are the outages that we face? Every incident should be logged. What are the incidents that were done, and what should be the actionable that we take from that. Then architecture integration, we have to look into the consideration about the when we do the capacity assessments in the early phase, then all new features, all the system changes, we have to look into consideration. Shared ownerships, it is not just the ownership of performance engineers or QAs, it is the ownership of everyone. So capacity planning isn't just a ops problem, everyone from business till the end, everyone is responsible in this. So this is monitoring and alerting of the capacity health. We have real-time dashboards where we can visualize by putting the monitoring applications like Dynatrace, AppDynamics, and New Relic. We can put a real-time dashboards where we can see how many transactions, how many users, what is the resource utilization, which box is becoming a bottleneck. We can see that. Then trend and forecast alerts, as I mentioned in the previous slides, also we will have to put the alerts in while doing the monitoring, so that if and the alerts cannot be at the stage of failure. It should be at the stage. Okay, now we have to uh, uh, get ready to enhance either the box or enhance what the issue or to resolve the issue where it will occur. So that is trend and forecast alerts. Then headroom monitoring. Headroom monitoring is how much is the headroom left for every box or for every system parameter to grow. Because if we don't put a headroom monitoring, then you will not realize when there will be a outage, because somewhere or the other one of the boxes will go beyond their scaling, and you will not be realizing that okay, that where the problem comes. So this is a headroom monitoring. Then anomaly detection. Detection is that okay, on a regular day there is something which is fine, but suppose there is a hacker who is sitting in somewhere in China or where or anywhere in the world, and he keeps on hitting one of the APIs. So that is anomaly. That okay, this was not there yesterday. This has started today, and this is the same API that is coming, and we are being hit from this particular IP address again and again, or a different IP address, but there is the same API that is being called. So there has to be anomaly flag that also be put into picture, or there could be anomaly something like that. That okay, there was something which was not there earlier. Means there is uh, the person. There is a one person who has put around. If I talk about it in the sense of e-commerce, he has put around 200 uh, products in his cart. Now that you were not ready for that, so that is the anomaly that you detected. You uh, go there and you check for that. Then predictive scaling triggers. So there should be a predictive model in which you can trigger the scaling uh, in a manner, because you have to be and all this predictive scaling triggers can be done through monitoring, trend forecast, real time dashboard, because and alerts. Because as soon as you say that okay, you have once it reaches 75% one box, you auto scale that. So that is where the predictive scaling triggering should be implemented. Then we are when we say when I said that scaling should be very logical, you cannot do it blindly. So there are two things, that is vertical scaling and horizontal scaling. Uh, the vertical scaling is adding more resources, suppose CPU, RAM, and storage, to an existing server. Suppose there is a server which has 8 cores, and you put it at to 16 cores. So it is in a single server only. So that is a vertical scaling. What is the pros? Simple initial implementation. You are using a single same box, so it is a less infrastructure management. Then potentially better performance, but you get it for some time. You have and it works for single threaded application. What is the cons? Because you have a single box, you can scale it to a particular limit. So that is where a finite limit comes into picture, and you have a single point of failure. If you do not have a boxes, you don't have a load balancer. So if you get a large number of users all of a sudden and one box gets failed, then it's a complete failure of the system. But when we put a load balancer or we put a multiple machine, then what happens that the load can move on to the another system. So that is another box. So that is where we can get rid of single point of failure. Then uh, when you have a high tiers system, then the high cost per unit of capacity. Then where it is best for applications with the strong state dependencies, relational databases, reaching moderate loads, simpler architecture where the load is always constant. There is a simple architecture. Lamp stack is one of the examples that we can talk about. Then horizontal scaling is more of a that we are increasing the resources and the servers. So adding more servers or instances to a resource pool. So that the load that is there, it gets distributed along all these servers. And now what will happen that you will have you don't have a single point of failure. You have four boxes which are handling the system, and they are at a very low level of they have a very moderate resource utilization. So there is a limitless scalability. You once your four boxes are utilized, you put another four. So a limitless high availability, definitely, because you have put a process of fault tolerance. So if there is wrong with one machine, one box, second box is working fine. So it is a high availability, cost effective at particular scale. At a certain point, it is cost effective. Uh, Obviously, when you have a high availability, you would have a zero downtime for capacity adjustments, because if you're doing a capacity, if you want to tune one box, then you don't have to shut down all the other boxes. You can do it while the other three boxes are running. What is the cons? Obviously, when you put more boxes, the complexity of the infrastructure increases. Then you have a distributed data. You have to use load balancing. Then it is majorly used for applications where there is a distributed environment. We have a large chunk of examples of these where we have stateless web servers, microservices, distributed systems, high traffic applications with unpredictable massive loads, e-commerce, banking. So these are the scaling strategies that are common, that is vertical and horizontal. Then effective testing, we have like load testing, stress testing, realistic simulation, chaos engineering, and interpret results. So this is the testing performance testing strategy that we follow. We do a simulated expected traffic to measure performance under normal conditions. Okay, fine. In normal condition, it is working fine. Now, in stress testing, we push the system beyond limits. Okay, now it was working fine for 1,000 users. Let's do it for 5,000 users. But let's see if it is able to bear that or not. Then there is a realistic simulation. Realistic simulation in which we say workload modeling. Workload modeling means when the user comes into the system, how does it behave? What is the maximum number of APIs that it uses, or what is the workflow that he follows? So that is also one of the things that is a realistic simulation. Chaos engineering. Chaos engineering was earlier called as chaos monkey because it was uh, working as a monkey. It used to inject failures in the environment like anything. It was jumping from here and there, and it is most majorly used to see the whether your system is fault tolerant or not, or it is high available or not. Because if as a chaos engineering, when you switch it or your system is running fine, there are transactions that are going on, and you shut down one of the box, whether your second box is able to handle the other load or not. So that is where the chaos engineering comes into picture. Then the final thing, we interpret the results. Whether after doing all this, whether we will be able to handle the load that business expects from us or not, or what is the bottlenecks that we have identified, or where we want to do the scaling, or where the box capacity is fine and we just have to tune that. So that is all the results that we interpret after doing all this. Any questions from this? So this is identifying bottlenecks and constraints where where we have where we majorly see the bottlenecks and where what are the constraints that we face. So database query performance identification could be slow query logs, high database impact is slow application, connection pool exhaustion, user timeouts. Then when we say connection pool exhaustion, then the second thing is connection pool, where the exhaustion, the identification is the errors in the application logs that it gives maxed out connection counts to database services. It has also application outages, inability to process request. Then comes the API rate limit. So identification, how do you identify that? HTTP 429 errors from external APIs, high error rates in API monitoring. Partial services degradation, data inconsistencies, because this is the third party. So there is a delayed processing. The network bandwidth saturation, that is one of the things that we have to see when we test or do the capacity planning. We check for the payloads of the APIs, that the response that they are bringing. So because what happens if the network bandwidth gets choked and you have the high network latency and the packet losses can be up to 100%. So why? Because then the API is bringing too much data with it, and because of that, the size it increases it actually utilizes the complete bandwidth. So it has overall performance becomes slow. There are timeouts, unreliable communication. The second thing, the another thing is cache. Cache hit ratio is actually you increase load on the original data source. You don't put the caching where it is required. If suppose there is a application which is for I take an example of Ghana. You have a song of a week. You put it. You every time the user hits and you take it from the original source, you are doing a disaster over there. So there is always a caching mechanism that you put into picture. That okay, so at least for a week it will not be refreshed. So the things that are not changing regularly or they are not changing dynamically, you can put it in a cache. Then message queue depth increases queue size. Suppose you have uh, used a message queue where you have kept like you're putting the messages in that queue. So what happens when you start triggering them? Then there is a delayed asynchronous task that gets into process. Then consumers failing behind. Impact is that latency in background jobs, the stale data produce resource exhaustion. So it happens when sometimes this is the case with the bad jobs in which you are processing the data at the 11th hour, and you have too much data that you haven't processed in like I would say around 24 hours. It is quite a big time, but I'll give you an example of 24 hours. So you will have first of all you will have the old data that is not the correct one, and second and the another point is that you will actually might be able to exhaust the resources that you are working on. Then the third party service limits that we have already discussed, that there are third party services that are already integrated with your application, and if you are uh, isolating your system and you are thinking only about your system, then that is another mistake that businesses do, organizations do, that they don't look into the limits that is provided by third party. So this is how the forecasting demand can be done. If suppose you go into the organization where you don't have where the business doesn't have any idea. Okay, I'm not. We are not clear what how to define the forecast. Then this is the as a performance engineer capacity planners. You can do that. You can look into the historical trend analysis, a seasonal pattern. Suppose you're going for an e-commerce website. You say, okay, give me the data for the Holi, Diwali, Dashera, the Christmas or New Year. So you give me the data for that seasonal pattern modeling, then marketing projections. So you sit with the marketing team and you say that okay, what is the forecast that you are eyeing at with your campaigns and promotions that you're doing. So marketing projections, then business growth targets. So you talk with the business that okay, what is okay? You don't tell me the users. You tell me what is the growth that you're looking at. Then also you look into the as the external factor analysis. We look into the market conditions. What are the competitors, and what is their numbers. Then on that basis, we define the forecasting for the that particular organization in which we are not provided any data. So that is that is this is how we these are the methods and approaches that we follow for forecasting demand. Any questions on this?
So, will we doing some kind of case studies on how we actually do this in real world?
Yeah, yeah. That is what I said. That we have our 7 modules, and we will do
Okay.
it in a later. In we'll go session by session because the first module is actually a foundational module in which I'll have only 5 sessions. So in this in these 5 sessions, I'll give you the foundation that okay, this is what capacity planning and is and what we will be discussing. I think I'll put it in the first slide. I'll go back and show it to you. Okay. But there are 7 modules that we have actually planned for this capacity planning, under which we will have total of 32 sessions. So this is the key metrics for capacity planning: request per second, then error rate, memory utilization, network bandwidth, database connection pool, P95, P99 latency. That is the 95, 99 percentile that we see. CPU saturation and then API rate limit headroom. These are few of the metrics that we will be discussing going forward. So this is it. Any questions, any queries from anyone?
Hey, do we have any type of tool or any type of certification needed to do a capacity planning? Means I'm
No,
just no, right?
no,
It's just a
no.
knowledge based.
Yes, yes. So if you are a performance tester, currently
Mm-hmm.
what we are seeing in this in the organization as a trend that as a performance tester, you are the companies won't pay you if you are just doing executing these scripts and you are providing them with the results, and you
Exactly.
say okay,
Yeah.
I will log a ticket for you and for a dev, and they will be helping us out with the resolution. No, they are not looking for that. They are looking for the people who can help them end to end. You do the test execution, you find the bottleneck for them, you find the root cause for that issue, and you find the resolution also.
Got it. Yeah. Yeah, that we know. I'm also doing the same. I'm in a performance testing and I'm doing almost the same what you just shown. One more question. Sometimes I got a question from my team.
Mm-hmm.
Like we are a product based, and we launched a new product now, and
Mm-hmm.
they are telling me just how you can tell us that means we don't know how many users will be there or something. Then will that type of questions will be covered? Means you are getting my point.
Yeah,
What
that
I
is,
mean to say.
yeah, I got it. I got it. That is what I discussed in the forecast. That
Yeah.
currently, if we go into the organizations where, as because I'm in a service base, so we face these kind of questions regularly because there are few of the organizations where they are not aware of what is the forecast that they are looking at. But
Hmm.
so in that case, what we see is we see the historical data that they have. Okay, over the period of 1 year. On an average on each quarter you have got 500 users increased, then I'm predicting that in next year you will have these many users. Suppose in if I say that in 4 quarters you had 2000 users, or
No,
2500 or
I
3000. You
yeah,
got it?
yeah, with the historical data, it's fine. But suppose they don't have historical data, that's a complete new application. Then do we have to check the competitors, or
Yes.
means how
Yes.
that would go?
In that case, we will have to look at the competitor. We have to look at the market growth. That okay, what is the current market growth that we have? So in that case, if you don't have the historical data, if you don't have the logs, then you have to check for the competitor
And
data and sit with business
with
that yes, go ahead. Go ahead.
yeah, with the user volume, we are able to just find out that how much the infra will be needed, right? That type of thing.
Yes,
That can be
yes,
covered.
yes.
Yeah.
Agreed.
Okay.
Because so capacity planning is done on the basis of the users only. That how many users or how many how suppose there is the user count can be less, but the transaction is very high. So it means that the users are doing the 10,000 users are only doing the so many transactions. Suppose, but you have millions of users, they are doing the transaction, then both these factors are affecting the capacity planning. So you have to think from that perspective that if you have a user base, then what is the workload model that you define? That okay, if I
Yeah,
define
means
this workload model, then
my question is surrounding to this only. Like we are going to take these types of example in our classes.
yes,
Like
yes,
yeah.
definitely.
Okay, then fine. Like we have multiple questions regarding to that one particular area, but I just
No issues.
wanted to get clear that everything will be get covered because this is really
Yes,
helping. Yeah,
yes,
thanks, man. This really helpful. This is really yeah. Thank you. Yeah,
thank you. Yeah. So means this is what we will. I've just given you a gist in this session that this is how the all the sessions will be and what we'll be covering in the next 32 odd sessions. Is it clear? Any questions? Any points from anyone? Okay. So I think we are good then. Thank you everyone. So good to see you all connecting here, and we will connect again for the next session. Thank you.
thank you. Thank you.